The U.S. Air Force has changed jet engine design completely. On March 21, 2025, President Trump introduced a new engine for the F-47 fighter jet that can change itself mid-flight at speeds over Mach 2. This adaptive cycle engine saves fuel when needed and delivers full power in seconds, a huge leap in aviation while other countries still use one-mode engines. This engine is so advanced, it feels unreal. 3 airflow paths that adjust in flight. China's and Russia's jets can't keep up. It's not just power, it's a new era in air combat, with over 1,000-mile range at Mach 2 plus speed. This engine creates more electricity than some power plants and stays invisible to enemy radar. Welcome back to our channel to Skyjet Wings, where we uncover the tech that keeps America ahead. The F-47's engine is a game-changer that's reshaping aviation. On March 21, 2025, President Trump, alongside top defense leaders, revealed the breakthrough that stunned the Pentagon and rewrote aviation history. The F-47 wasn't just another jet, it had an engine so advanced, it had been secretly flying since 2020. While other nations doubted such tech could exist, President Trump confirmed it was the most powerful jet ever built, far beyond anything rivals had. But power was just the start. This engine also delivered unmatched fuel efficiency and stealth. While others were still designing, the US was already flying hundreds of test hours, perfecting the impossible. The F-47 engine is like having 2 different engines in one. Named after the P-47 Thunderbolt, this new jet makes its World War II ancestor look outdated. It uses propulsion tech never seen in real aircraft before. Boeing won the $20 billion contract not just for the plane design, but for fitting in this game-changing engine. It sounds like sci-fi, but it's real. The F-47's adaptive cycle engine has aviation experts rethinking everything they know. It completely changes how jets create thrust and manage power. Traditional jet engines must choose between fuel efficiency or high performance, never both. It's like picking between an economy car and a race car with no way to combine them. But the F-47's adaptive engine changes that completely. Developed by General Electric, XA-102, and Pratt & Whitney, XA-103, this engine has a 3-stream adaptive cycle design that changes mid-flight. It shifts between fuel-saving mode for long range and high-thrust mode for combat instantly. Inside, airflow paths reshape themselves, and smart systems adjust everything in real time, thousands of times per second. It's engineering at a whole new level. In real combat, this engine changes everything. An F-47 can fly over 1,000 nautical miles across the Pacific using minimal fuel. When enemy jets show up, the engine instantly boosts to Mach 2 plus speed and powers all onboard systems. But it's not just switching between 2 modes, it adjusts to any level between fuel saving and full power. Need speed with some fuel efficiency? Done. Need low heat to stay stealthy? It reduces thermal output. The third airflow stream gives unmatched control over thrust, fuel use, and heat. And it doesn't stop at flying, the engine also acts as a high-power generator, producing more electricity than any fighter jet before. This engine isn't just for flying, it powers advanced combat tech. It generates more electricity than many ground facilities, running the F-47's radar, electronic warfare tools, AI systems, and energy weapons. Unlike traditional engines, it produces power without losing thrust. Its smart cooling and airflow systems manage heat and keep the jet stealthy by reducing its infrared signature. The F-47's adaptive engine controls its heat output, making it nearly invisible to infrared sensors. It generates enough power to manage drone wingmen and advanced systems without losing performance. Stealth is built into every part of the engine: heat, sound, and radar. It uses smart airflow to cancel noise, special inlet designs to avoid radar detection, and materials that absorb radar signals. Even the exhaust is engineered to stay hidden. The F-47's engine cools and disperses hot exhaust to stay hidden from infrared and radar detection. Its cooling airflow also reduces heat visibility during key missions. Even with high power output, the engine keeps electromagnetic emissions low for full stealth. Most importantly, its long range changes everything, allowing U.S. air power to reach deep into the Pacific, reshaping strategy across the region. Current jets like the F-22 and F-35 need frequent refueling in the Pacific, limiting their range and exposing them to threats. The F-47's adaptive engine solves this by flying over 1,000 nautical miles without refueling, while still ready for combat. This allows the F-47 to launch from safer bases, avoid enemy missile zones, and still reach key targets. Its airline-like cruise efficiency and instant combat power give it unmatched patrol range and flexibility, making enemy defenses easier to outmaneuver. The F-47's adaptive engine gives it unmatched range and flexibility, making U.S. fighter operations unpredictable. Enemies can no longer guess where threats may come from. In combat mode, the engine delivers extreme power, far beyond current jets like the F-35. It accelerates rapidly, shifts to sustained high speed, and reaches over Mach 2 with ease. This engine redefines air superiority, pushing the limits of what fighter jets can do. The F-47's adaptive engine boosts maneuverability with powerful thrust vectoring and advanced flight controls. It delivers unmatched agility, as President Trump said, like nothing ever seen. Unlike older jets that burn fuel quickly in combat, the F-47 balances power and fuel use, allowing longer fights. Its engine responds instantly to pilot commands, almost like reading their mind. Even more impressive, it powers coordination with drone wingmen. Each F-47 can control multiple unmanned aircraft, extending its reach, firepower, and sensors, redefining air combat with true team-based air warfare. The F-47's engine generates the power needed to control multiple drones in real time without losing performance. Pilots can send drones ahead for scouting or coordinate group attacks, staying safe while overwhelming the enemy. Even during high-speed flight, the engine manages drone communication across different speeds and altitudes, something no traditional engine can support. This gives the F-47 a huge tactical edge. Building this engine is a breakthrough itself. It's made with extreme precision, parts are engineered at microscopic levels. Boeing's facility uses advanced techniques and materials never before used in jet engine production, pushing U.S. manufacturing to a new level. The F-47's engine uses cutting-edge materials, heat-resistant alloys, radar-absorbing composites, and electromagnetic shielding, all without compromising its adaptive design. Every part is tested to ensure peak performance in all modes. Boeing began building advanced production systems even before the official contract, showing their confidence in delivering at scale. New training programs were created just to prepare skilled workers for this complex manufacturing. This engine doesn't just boost U.S. air power, it sends a clear global message: America is years ahead in fighter jet technology. The F-47's adaptive engine forces rivals to rethink their entire fighter jet strategy. China's latest stealth jets still use outdated engines and can't match the F-47's tech. Russia faces even bigger hurdles. They haven't mastered reliable conventional engines, let alone adaptive ones. The gap is growing, not shrinking. U.S. allies are eager to get access to this game-changing engine, and export versions may offer scaled-down tech. Countries without adaptive engine capabilities risk falling permanently behind in air combat. This tech edge also boosts global stability. Few will dare challenge U.S. air power. Behind it all is a flight test program that proved what once seemed impossible. Since 2019, experimental aircraft have proven that adaptive cycle engines work in real combat conditions. Through the DARPA X-plane program, these jets logged hundreds of flight hours, showing they could switch modes during intense maneuvers without failing. The engines held up under extreme stress, with durability that even beats traditional designs. Flight tests confirm the F-47's engine delivers on every promise: range, speed, agility, and power. While rivals test in public, the U.S. kept its breakthrough secret until ready. This quiet success shows America's unmatched lead in advanced fighter tech, and highlights the strategic vision driving this revolution. The F-47's adaptive engine is more than a tech breakthrough, it's a bold strategy to keep the U.S. ahead in air power. Air Force leaders knew small upgrades weren't enough for future wars. They needed something revolutionary. This engine meets the challenge, offering long range, high performance, and the power needed for AI and drone coordination, all while being upgradable for years to come. Built with allied cooperation and designed for future needs, it's a cornerstone of modern defense. In short, the F-47's adaptive engine is the biggest leap in fighter jet propulsion since the turbojet, redefining what's possible in air combat. The F-47's adaptive engine isn't just a technical marvel, it's a symbol of America's unmatched commitment to air dominance. Built for the brave pilots who risk everything, this engine delivers raw power, long-range performance, and life-saving reliability. It guarantees that U.S. aviators will always fly with an edge no enemy can match. Boeing's success proves that when America supports its industry, innovation thrives. This engine doesn't just shape aircraft, it shapes global strategy. As rivals scramble to catch up, America is already leading the future. The era of adaptive cycle engines has begun, and it belongs to the United States. If this groundbreaking engine left you amazed, don't forget to like the video and subscribe to Skyjet Wings for more exclusive insights into the cutting-edge tech powering America's air dominance.